Hi everyone, today we're going to study properties of probability. Let us consider some properties of probability, and this is the first one. The union of two events, E and F, denoted by E union F. Take note that the union is symbolized by U, is the set of outcomes that are in E or in F or in both. The second property, the intersection of two events E and F, denoted by E intersect F. Take note that the symbol for intersection is an inverted U, is the set of outcomes that are in both E and F. Property number 3, two events E and F are said to be mutually exclusive or disjoint if they cannot occur at the same time. That is, E intersect F equals 0. In relation to the union and intersection of events, we have this addition rule. It says the probability of the union E and F equals probability of E plus probability of F minus the probability of E intersect F. Property number 4, the complement of an event E, denoted by E with exponent C, is the set of outcomes in the sample space that are not in E. We have this formula: the probability of E complement equals 1 minus probability of E. Let us have some examples. Here is example 1. A card is drawn from a standard deck. Determine whether the pair of events given below are mutually exclusive. Event E, the card drawn is an ace. Event F, the card drawn is a heart. First, let us see all the cards in a deck of cards. Next, the ace of hearts belongs to both sets. This is the ace of hearts, means the E intersect F, that is the ace of hearts, is not equal to 0. Therefore, the events E and F are not mutually exclusive. This is our final answer. Let us have example 2. A family has 3 children. Determine whether the following pair of events are mutually exclusive. Event M, the family has at least 1 boy. Event N, the family has all girls. For the solution, we will write first the sample space that consists of 8 possibilities. This is our sample space. Next, we will list both the sets. For the set M, we have BBB, BBG, BGB, BGG, GBB, GBG, and GGB. For event N, only one element, and that is GGG. Clearly, we can see that M intersect N equals 0, or we say there is no common between M and N. Therefore, the events M and N are mutually exclusive. This is our final answer. Example 3. If a die is rolled, first question, what is the probability of obtaining an even number or a number greater than 4? Question 2. What is the probability of obtaining an even number and a number greater than 4? For our solution, first, let us assign E, this is the event, for an even number. And let F be the event for number greater than 4. Let us write the sample space, and that is numbers from 1 to 6. Then let us write event E, whose sample points are 2, 4, and 6. For event F, elements are 5 and 6. For the first question, we will solve even number or greater than 4. We will write here E union F. Take note, the word or here denotes union of event. So we have the elements 2, 4, 5, and 6. Now, for the probability of E union F, this is equal to the fraction 4 over 6. We write here 4 because there are 4 elements in our E union F. We write here 6 because there are 6 elements in the sample space. And then we will simply reduce this to lowest term. So we have 2 over 3. Let us answer the second problem, and that is even number and greater than 4. So we write E intersect F. Take note that this word "and" here denotes intersection of events. So this is equal to the set with element 6. Therefore, the probability of E intersect F equals 1 over 6. We write 1 here because there is only one element of E intersect F. Again, we write number 6 here because there are 6 elements in the sample space. Let us have example 4. If a card is drawn from a deck, use the addition rule to find the probability of obtaining an ace or a heart. First, let us assign A to be the event that the card is an ace. Then, we let H to be the event that the card is a heart. Since there are 4 aces and 13 hearts in the deck, and we know that the sample space equals 52, so we write here the probability of A equals 4 over 52, and the probability of H equals 13 over 52. Furthermore, since the intersection of two events is an ace of hearts, so we write P of A intersect H equals 1 over 52. Then, for the addition rule, we write here P of A union H. Take note, we see here the word or that denotes union. And this is equal to the addition rule. That is equal to P of A plus P of H minus P of intersection of A and H. So we do the substitution. P of A is now 4 over 52 plus the P of H is 13 over 52 and minus the P of A intersect H, that is the 1 over 52. And when we do the operation, we have 16 over 52. We reduce this to lowest term, and that will be equal to 4 over 13. This is now our final answer. Example 5. 2 dice are rolled, and the events F and T are as follows. Event F, the sum of the dice is 4. And event T, at least one die shows a 3. Find the probability of F union T. First, let us remember we have a table that shows rolling of 2 dice. Then we list the event F and event T and the event F intersect T. Let's begin with F, and we have here 1 3, 2 2, and 3 1. Next is the event T. So we have here many elements, starting with 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 1 3, 2 3, 4 3, 5 3, and 6 3. Now, for the F intersect T, we have 1 3 and 3 1. Then, let us write the addition rule. So, this P of F union T equals the P of F plus the P of T minus the P of F intersect T. So let us do the substitution. P of F will be 3 over 36. We write here 3 because there are 3 pairs in the event F. Over 36, there are 36 possibilities of pairings. Then plus the P of T, so we have 11 over 36. We write here 11 because there are 11 pairs in our event T. Over 36, again there are 36 possibilities in the rolling of two dice. Then minus the intersection. So we write 2 over 36. We write here 2 because there are two pairs in our F intersect T. And then let us operate the three fractions, and the answer is 12 over 36. Let us reduce this to lowest term, so we have now 1 over 3. This is now our final answer. Let's have example 6. The probability that a student in the college owns a car is 1/3. What is the probability that a student does not own a car? First, let us acknowledge that the P, or the probability for student owns a car, is 1/3. The problem is asking about the probability that the student does not own a car. Take note that these two events are complement of each other. We have a formula for the complements. So we have here P of complement of an event equals 1 minus P of the event. With regard to our problem here, we may write the P that student not own a car equals 1 minus P, or probability that a student owns a car. Let us simply substitute the value in our P, student owns a car, and that is 1/3. So we have 1 minus 1/3, and the answer is 2/3. This is the probability that a student does not own a car. This is our final answer.